What do you make of this tail? Is it a tail? Is it not a tail? Is it maybe forming a tail? What do you
No,
make of that?
currently there is no evidence for a tail the way we see around comets. The best image we have was from the Hubble Space Telescope, and it shows a glow of light ahead of the object with no trail of dust or gas behind it. Since then, we had a bigger image of the object in carbon dioxide, actually, that shows a large cloud of carbon dioxide around it. And that cloud is symmetric. It doesn't extend the way cometary tails do. There is no evidence for a water cloud around it, so it's probably not a water-rich comet. And it's not clear that it's a comet because the carbon dioxide may be just ice that collected on the surface of the object. And even over a period of a year, the amount of material needed to be supplied for this cloud that is maintained around it is accounts to less than a millimeter thickness, a very thin layer, basically the skin of the object. The question is, what is the nature of the object under that skin? And this could be just dirt that collected on the surface, irrespective of its nature. It's not clear to me that there is any evidence for dust, because the object appears red, and some people interpreted that redness as being the result of a cloud of dust around it. But in order for the dust to redden the sunlight reflected from the object, the particles have to have a size comparable to the wavelength of sunlight. And if they had that size, they would immediately get pushed behind the object. Within a day, they would trail it in a beautiful cometary tail. And we don't see that. So I would be actually surprised if there is much dust coming off the object.
Sure.
And so we currently are not seeing the telltale signatures of water-rich comets. And the reason I was intrigued by this object in the first place was the fact that its brightness, if there is no dust, then most of the light that is reflected from the region around it comes from the object itself. And if you do the calculation, you find that it needs to be bigger than of order 20 kilometers in diameter. The latest data from the Spherex Space Observatory suggests a size that goes up to 46 kilometers, and that's huge. And the reason I found it surprising is because the previous interstellar objects, Oumuamua was the first one in 2017, and then after that there was a comet called Borisov. Both of them were on the scale of hundreds of meters.
Okay.
And if this object is 20 kilometers, it means that it's about 1 million times more massive than these objects. And we should have seen millions of smaller objects of the scale of Oumuamua and Borisov before seeing one as big as 20 kilometers. We haven't. This is the third one, so that will be quite
It's about
unusual.
Mount Everest, right?
Yeah. I mean, two small ones and then a giant one. And moreover, there is not enough rocky material in interstellar space. I wrote a paper about it on the 4th of July when my wife took me on vacation. I just couldn't resist writing a paper saying, if you just estimate how much rocky material there is in interstellar space per unit volume, even if you package all of it in 20-kilometer rocks, you would expect one of those rocks to arrive at random to the inner solar system once per 10,000 years. And we have just monitored the sky for a decade. So how come we observe such a giant rock? And so then it led me to suggest either this object is much smaller and we are fooled by something like a cloud of dust around it, but now we don't see that dust as a cometary tail. Or the alternative is that it didn't move on a random trajectory. The trajectory was targeting the inner solar system, meaning that perhaps it was designed by some intelligence, but it's a technological object. And in that case, I looked at the orbit. The trajectory of this object appears to be aligned with the plane of the planets around the sun to within 5 degrees. And the chance of that happening at random is 1 in 500. And moreover, it comes very close to Mars, Venus, and Jupiter. And if you just follow the trajectory and just not even change it, but just arrange for a random arrival time, the chance of that alignment with the planets would be 1 in 20,000. So that suggested that it may be technological in origin. And of course, the way to settle it is by observing it, getting as much data as possible as it gets closer to the sun. And, if it, right now, I give it a rank of 4 on a scale that is now called the Loeb scale that I invented in July for this object, where 0 is
a rock.
Implies, a rock, a natural object. 10 is an object that is definitely technological, that may be a threat to Earth. For example, if the object maneuvers or broadcasts a signal or emits artificial lights. And we don't have those technological signatures as of yet. I gave it a 4 as of now. But if you go down the street and you see a car approaching you and you give a 40% chance that it will run over you, then you better watch that car. And so my point is simple. We should keep our eyes on the ball and monitor this object, because if it happens to be technological, the implications could be huge for the future of humanity. And I'm not just talking about us recognizing that there is another civilization in our neighborhood, but also it could be a threat because we don't know the intent. If you have a visitor to your backyard, the visitor, first of all, it's an imminent threat. You have to decide what to do about it, because that the visitor may enter through your front door. And we've never contemplated such scenarios before. We thought about the radio signals that we might receive from far away, thousands of light years away, where you have the leisure of responding after a while. You don't need to worry about an immediate risk from that. And so it will open up a completely different perspective of that could lead, for example, to a decision to employ an array of spacecraft in orbit around the sun that would protect the Earth, basically monitor any object that enters the solar system from outside and try to figure out if it's a threat to humanity. And we can use a set of interceptors or monitors that take images of incoming objects to tell us whether any of them might be a threat. And we just haven't thought about such existential threats. We often talk about artificial intelligence as a potential threat, or a global climate change, or an asteroid impact, but we don't discuss alien technology.
Yeah, and we saw you, what was it, about 3 months ago when you presented to Congress with the UAPDF. They're sitting down with Representative Burleson, Burchett, Paulina Luna. You gave about a 30-minute presentation. At that point, we didn't know much about 3I Atlas, right? You presented mostly with the
It was not found.
It was not found.
No, it was discovered on July 1st, 2025. And this briefing was May 1st, 2025.
So you just missed it. I mean, you had one more piece of information we could have shown them, right? But you definitely had the Oumuamua case, and you showed them how 91% of that surface would have been flat, right? Based on when the way it reflected light when it was tumbling, we were able to surmise that. So I'm wondering, are we making any formations of this object yet to where you can give us some numbers around, just like you said with the Oumuamua, it's probably 91% flat, right?
Well, these are very different anomalies. That Oumuamua was anomalous in terms of its shape, as you say, most likely flat, and it was also pushed away from the sun by some mysterious force without showing any evidence for cometary evaporation. There was no gas or dust around it, yet it was exhibiting non-gravitational acceleration. Now, this object is very different. 3I Atlas, the third object, is very big. That's one anomaly that you cannot accommodate easily with a rocky reservoir of material in interstellar space. And then, in addition, it has an anomalous trajectory. And And also the great advantage of this object is that it's now entering the solar system, so we can actually get more data on it. With Oumuamua, it was leaving the solar system when we noticed it, and we didn't get enough data on it. So my hope is indeed that we will observe it with all the assets that we have, not only on the ground or the telescopes, but also in space. There is a camera near Mars. It's part of the Mars Reconnaissance Orbiter, and it's a half a meter in diameter aperture that could resolve 30 kilometers at the distance that the 3i Atlas will be on the 3rd of October when it comes closest to Mars. And so I encourage the team that operates this camera to use it. I also wrote a paper about using a spacecraft near Jupiter that is called Juno. It could have potentially intercepted 3i Atlas if it had enough fuel, if it had all of its initial fuel. But even with much less than that, it could get close to the path of 3i Atlas when it comes closest to Jupiter on March 16, 2026. And I actually wrote a paper about this, and because Juno was supposed to crash into Jupiter and in mid-September 2025, and I suggested just pushing it away from Jupiter instead of into Jupiter so that we can use it to learn more about 3i Atlas. If the object itself maneuvers in ways that cannot be understood just by the law of gravity, then the stock market may crash. I had a fan that was reading my essays. I write an essay almost every day or two on medium.com. You can find a lot of updates there. And he said that he decided to trade options on the volatility of the stock market with an expiration date of October 29th, just in case this object ends up being technological.
Yeah, and we're getting a lot of questions here in the chat, live chat. We have a lot of folks on. Thanks, everybody. Be sure to like it if you enjoyed the discussion. We're getting a lot of questions about the signals, and you talking about it not emitting a signal, not as of yet. So we're getting some questions on that from the fans listening along here, such as Gene Sticko here says, is it only a distance that keeps you from reading the signals of whether natural or not at this point? We also had another question about the signals from Jock the Hydra. It says, are we certain it isn't emitting signals in some way and we haven't thought to look for? So, is there a point where it comes close enough to where we would know that? Or
I mean, we could have detected the signal if it were transmitting it. The question is whether any of the observatories that are capable of detecting.
So you believe we do have the tech to be able to observe from the distance it's at right now?
Oh,
if it were.
It depends on the power of the transmitter, but we have radio telescopes, we have a lot of optical telescopes and even X-ray and gamma ray observatories that can be looking for a signal, but so far nothing was reported. I don't know if radio telescopes are listening, because if it's a natural object like a rock, nobody expects a radio signal, but nevertheless, it's worth checking. So the data that was released so far involves images. We can't really resolve the object itself because it's so small. It looks like a point source, even in the Hubble image or in the most recent SphereX image. But we know that on August 6th, this object was observed by the Webb telescope, and that is the most interesting data to look forward to, but it wasn't released yet. The data is still under wraps, and it's not clear what exactly is the nature of the data.
Yeah, let's talk about that, because I was going to have a question for you on that. It's my belief that disclosure will not come from Congress. It won't come from catastrophic disclosure where the alien presents itself to us. I believe disclosure will come from that platform, the James Webb Space Telescope. But my worry is suppression. What are we dealing with there? Can you help us understand data gathered by that platform? What kind of back channeling exists there that we're going to have to be worried about not being, data not being presented to us off of that platform? Because, I mean, you just mentioned it.
Well, no, I think you shouldn't worry too much, because the way the data is handled is completely open and according to procedures. So in principle, there are people who propose to use the James Webb Space Telescope to observe objects like 3I Atlas, interstellar objects. So they got time to observe it, and that was the data collected on August 6th. And according to the rules of the Webb telescope, they have 3 months during which the data is at their disposal. They're not obligated to release it. That's completely understandable when you deal with observing, let's say, galaxies at very large distances. Nothing much happens over a few months. But in this case, the reason that we really want it out so quickly is because the object is moving. And in 3 months, it will be moving out of the solar system. We want to know as soon as we can what can be learned from the Webb data so that we can design other observations as follow-ups. And that's why the urgency. But the rules of the Webb telescope allow whoever collected the data to keep it to themselves. Now, they could have already released it because the Hubble data was released within a couple of weeks, and the SphereX data was released within about a couple of weeks. And we could have had the Webb data released, in a scientific paper within a couple of weeks, unless, there could be also some challenges, scientific challenges that they are encountering. For example, the field of view of the Webb telescope is rather small. It can look only on, about a few arc minutes on a side, and that may be not big enough for them to calibrate the background flux of infrared light that they are detecting, and so they can't really tell if there is a a cloud of emission around the 3I Atlas, maybe. And also there are obviously background stars in that image that they're taking, and they need to somehow separate the emission from 3I Atlas from background stars. And these are challenges. And I would say as of now, the delay is still reasonable. If it's a matter of weeks, if we don't see a release within a month, then it would start looking as if they have an issue that they cannot resolve. But eventually by November, November 6th, the data will be out no matter what, even if the team that is analyzing it has difficulties, everyone will be able to access that data.
Yeah.
So don't worry, there is no way by which, it's not like government data that is classified. In this case, it's available to the scientists that are currently looking at it. It's just that it's not available to the public until they decide to make it available or until the 3 months expire.
Sure. Thanks for clearing that up. Yeah. With propulsion, for example, and you're talking even, you mentioned maneuvers or any type of maneuverability or change of trajectory. We did have a question from UAP Reporting Center on X. He says, if 3I Atlas were under propulsion, what signature would you expect from a nuclear-powered system at such distances, and is there any existing data hinting at that?
Well, so the obvious signature would be non-gravitational acceleration. If you have propulsion system, you should see deviations from the trajectory that you expect just based on gravity. And that was seen in the case of Oumuamua. We saw a deviation from the trajectory expected by gravity, but we haven't seen any rocket effect from a cometary evaporation. So that's why it was anomalous in my view. And I suggested that it's being pushed by reflecting sunlight, like some technological objects that we launched to space, appear. And in fact, 3 years later, the same telescope in Hawaii discovered an object that is being pushed away from the sun by reflecting sunlight, and it ended up being the upper part of a technological object, a rocket booster that was launched by NASA in 1966. Yeah. It's called 2020 SO. So that was in the case of Oumuamua, but in this case, it could be actually a functioning device that would maneuver not because of reflecting sunlight, but because it has an engine, as the question is alluding to. And in that case, the non-gravitational acceleration could be much bigger and much more anomalous than reflecting sunlight. And we should be able to detect it. I haven't seen an analysis as of yet of the best data we have on the trajectory and what are the limits on non-gravitational acceleration. But I would be most interested in what happens when it comes closest to the sun, because that's the place where you expect to have maneuvers in order to get gravity assist from the sun. So let's see if there will be anything.